Excellent. Thank you for the introduction, Barbara, and thanks for moderating. I have the Q&A pulled up, so I'll be able to see questions posted in there. And I will take a break about halfway through to get through some questions, so feel free to drop things in the Q&A for me. And Barbara, feel free to jump in if there's something big that should be asked in the moment.
Great.
Thank you all for coming today. I really appreciate the time, and I'm looking forward to sharing with you some of the work that the Kensho team has been doing on the problem of named entity recognition and disambiguation, or as we call it, NERD. My name is Dominic. I've been at Kensho for almost 4 years now, and have spent a good chunk of my time working on NERD. And so very excited to dive in and share some of that work with you all. So I want to start by defining some of our terms before we go too deep. And so I have a little cartoon to go through that. NERD operates on text. So as you can see here, I've got a nice document sitting here full of some text that I want to better understand.
So hold on, I'm sorry to interrupt, Dominic. In the chat, they're saying that they can't, some people cannot see your video. So
they can't see my slides.
Let's try that again, perhaps.
Sure.
They have an orange square. Well, now I see the orange square. I see the orange block now.
All right. Thanks for catching me. Let me know if there's any other glitches along the way.
I don't know. Now I'm seeing the orange block. Everyone else. Are we supposed to be seeing an orange block?
Yes, you are.
Okay, good. Yay. No text, ironically enough. Very funny.
Yes. Well, you can imagine that.
David, that's hilarious. It's a lovely block.
Thank you. Thank you. This is chock full of some interesting text that we're interested in.
The spare is.
We're also interested in a set of entities.
Orange block recognition. I'm so sorry. This is hilarious.
That's all right. Now below, I've got some entities that I care about. Now, depending on the domain that you work in, this set of entities may be companies. It may be, general people, places, and things. Maybe if you're in the medical field, this is pharmaceuticals that you're interested in. And what I want to do is, for my nice piece of text here, I want to pull out text spans that I think might refer to these entities that I'm interested in. And what I want to do next, now that I have these text spans, is perform some matching. I want to link up those text spans to the entities that I care about below. And so again, we're referring to these blue blocks as my entities. You might also hear me in this talk call this the knowledge base. Really, by knowledge base, we're just talking about a set of entities. This first step I'm going to call recognition. So I want to recognize potential named entities in my text. And then this next step I'm going to call disambiguation. So that's the task of actually figuring out which of these text spans refer to which entities in my knowledge base. You may also have heard this second step referred to as entity linking, and that's also a valid name for this. It just doesn't really end up with as cool an acronym as NERD, and so we're going to call this recognition and disambiguation. And this whole process, named entity recognition and disambiguation. And here's what the output of our named entity recognition and disambiguation process looks like. Here I grabbed a snippet of text from an article I was reading, I plugged it into NERD, and you can see I've picked out the entities and I've tagged them back to some particular knowledge base. In this case, this is my general knowledge base that we use in NERD that's made up of Wikipedia pages. And so every entity I've picked out here is linked back to its Wikipedia page, and things highlighted in the same color refer back to the same entity. So now that we've talked a little bit about what NERD is, I figured it'd be worth just talking briefly about why NERD is actually useful. Why do we care about this problem in the first place? And I think the answer is twofold. The first is that it's part of this larger effort of converting the unstructured to the structured. When we have a bunch of unstructured text, putting it through NERD allows us to make that text much more searchable, much more understandable by pulling out those kind of key figures, the people, places, things, organizations within our text. I think the second piece is that NERD is this kind of foundational step in natural language understanding. If we want to know more about what a document is about and what are the key things that happen within it, a really good starting step is to understand, well, who are the key players? Where does this take place? When does this take place? And by doing NERD, we can get a really good understanding that will fuel downstream tasks. So NERD is helpful for structuring unstructured text, as well as for being a building block on top of more complex natural language understanding processes. So I've shown you my nice NERD cartoon here. I want to go a little bit more into detail. Now at Kensho, we've chosen very intentionally to split NERD into these 5 key steps. And I'm going to go through each of these in a little bit of detail next. Named entity recognition and disambiguation can be approached in a lot of different ways. We can approach this perhaps as one big monolithic model that takes in text and gives us output disambiguations on the other side. But we've chosen to split it up, and I'll talk a little bit about the reason why as we go on. But first, let me tell you about these 5 steps. First off, we want to extract mentions. So this is that recognition piece that we were talking about earlier. I've got my document and I pull out text spans that I think are named entities that I might care about. The next step we call co-referencing. So what we want to do is take these entities that we've picked out, these text spans, and figure out which 2 refer back to the same thing at the end of the day. And maybe we have more than 2, maybe we have a group of several of these that we think are actually referring to the same entity. This is helpful for computational reasons. At the end of the day, we're making fewer predictions, so it saves us time. But it's also helpful for getting stronger predictions because we can leverage context from each of these mentions to make a prediction about this whole cluster of mentions here. So Supreme Court is arguably easier to disambiguate than the court. If we're able to think of those as just a cluster of entities that all refer to the same thing, we can use the context of Supreme Court to help us get the court right later on. So once I've grouped my mentions together into these nice clusters, I perform candidate identification. So here I reach into my knowledge base of entities and I find the 3 or 10 or 50 best matches for that particular span of text. Now this again helps shrink my problem space down. It shrinks the number of things I have to make predictions on. For a lot of the knowledge bases we use with NERD, there are millions and millions of entities. And so it doesn't quite make sense to consider each of them as a potential match. We really want to narrow the field down to just a small subset of candidates. Next up, we create features. We look at these pairs of mentions and candidates, and we want to find some things that will help us disambiguate them. And I'll get into those features here in a little bit. And then the final step is to use a model to select the best prediction. So here we're treating this as really a binary classification task. We're looking at each of these individual candidates and we're making a yes/no prediction as to do we think this is the best match. And at the end of the day, we're taking the candidate that has the highest score from this model. And so this is the NERD process. These are the 5 steps that we've broken this down into. So instead of treating NERD again as kind of one big monolithic problem, we've broken it down into these individual subproblems. And the reason is that we really wanted to build NERD to be highly modular. we want a nerd to be able to adapt to a variety of use cases and problem spaces. And so we didn't want to just build one big monolith. We wanted these pieces that we could mix and match based on the needs of a particular problem that we're solving. So by building it in this modular way, we can switch out these components if, let's say, well, we're no longer interested in companies, we're actually interested in pharmaceuticals, or maybe there's a legal use case for nerd and we're interested in lawyers and judges as our set of entities. We want to be able to swap these things around without having to do a ton of heavy lifting, without having to completely start from scratch with each individual use case. And so I want to now talk about those nerd steps by thinking about each of these different components and the potential options we have there. There's a question that just popped up in the Q&A asking if we're using existing libraries, a mix of nerd-specific and open source code for this. So the nerd pipeline code is something that we've written ourselves, but the nice thing is that within that pipeline, you can use something open source, you can use something custom, and we'll actually talk about that right now, actually. So for this first step of entity recognition, well, maybe we just want to go out and grab an NER model from Spacey or Hugging Face. You know, there's a ton of really easy to use, just download and go NER models. There's also plenty of domain-specific NER models available. And so we do have cases where we just use an open source model and plug that in as our first step in nerd. Sometimes we go out and build a custom model in this case. And so one of our big nerd use cases is financial nerd. So we're really interested in picking out company names, organizations in financial documents, things like SEC filings and earnings call transcripts. And so in this case, we wanted a model that was really fine-tuned on those particular types of documents, on things like SEC filings. And so instead of using something off the shelf like Spacey or Hugging Face, we trained our own model here. And so what's nice about this is that where there is an open source tool available, we can plug that into this step. Where we need something a little bit more custom, we can train that and plug that in as well. So this next step is co-referencing. And co-referencing, I think, can be broken down into really kind of two broad categories of ways we solve this. There's kind of your simple rule-based co-referencing, where maybe we say, only consider things the same if their normalized texts match up, or if they have a certain edit distance from each other, or a certain amount of overlap in words or characters. But this is also another place where we can stick in a model to do this in a little bit more fancy way. So we can think about this as a clustering problem. You know, we have all these mentions we've pulled out, and we want to cluster them into those that we think all refer back to the same thing. We could also look at these individual mention pairs and make a prediction, yes or no, do they refer back to the same thing? And so again, depending on the particular use case, how important is good co-referencing? How much time do we want to spend on this step? We can swap these pieces around. Next up, we have candidate identification. And this is one of those steps that really depends on your set of entities. So in the case of Wikipedia, for example, if we're using Wikipedia pages as our entities, we have a ton of aliases available. Wikipedia is just really, really good at noting aliases. So for something like the Supreme Court, we have US Supreme Court, or Supreme Court of the United States, or SCOTUS. We have all of those things in our knowledge base. And so it's pretty easy to do something like, well, if the text span just matches a known alias, consider that to be a candidate. In other cases, we may not have access to as rich alias information. So going back to that case of financial nerd, we have this long database of companies, this long list of entities that we're interested in, but not a ton of aliases. And so we look at overlap between the text span and the name of the company in question. So if I'm looking at Kensho Technologies as my text span, I'm going to grab everything with overlap with the word Kensho, everything that contains the word technologies, and use that to identify my candidates. Now, of course, you may be able to guess that Kensho is probably a lot more valuable of an overlap than something like technologies or LLC or incorporated. And so we actually do a weighted overlap based on the IDF values, the inverse document frequency values of each individual word. And so that helps us know if you overlap in Kensho, you're probably a really good candidate. If you overlap the word technologies, there's a lot of companies that do that. It might not be that helpful. Next up, we have, I think, the fun part, the feature generation step. And there's a lot of features that we can build for each nerd use case. For just about any case, you have string similarity measures. And so we can look at just about every way of comparing strings under the sun to compare our mentioned text from the document with the names and aliases of the candidate in our knowledge base. We also may have some priors on just how likely it is for an entity to show up in a piece of text. So for Wikipedia Nerd, we use the count of monthly page views to understand how important an entity is, how likely it is to pop up in something like a news article. For Financial Nerd, we can use something like the market cap to understand how big a player a company is, and maybe that gives us some prior on how likely it is to show up in an earnings call transcript. We can also use other kind of metadata from our source document. If I'm looking at Tesla's SEC filing, well, that gives me some pretty good indication that Tesla's going to show up in there, but also maybe Tesla's competitors or Tesla's collaborators and supply chain are going to show up in that document with a higher likelihood. And then I think one of our most important nerd features is what we call coherence. So we consider how likely entities are to appear together, which lets us leverage context from other entity disambiguations in that document to make the right choice for the particular mention that we're considering. So here, if you have the text Supreme Court, it's actually quite hard to figure out if it's the US Supreme Court, Supreme Court of Belize, Supreme Court of Kenya. But if I tell you there's another mention that we've disambiguated to Kenya, and another mention that's been disambiguated to the Chief Justice of the Kenyan Supreme Court, you've transformed this pretty much impossible problem into a really trivial problem. It's very easy to understand, oh, when you see Supreme Court mentioned in context with Kenya, well, that's a pretty good indicator that the Supreme Court of Kenya is what's being talked about here. And then last thing that we do is pass those features to a model. And Nerd is pretty agnostic to the model that you want to choose here. You can really use this as an opportunity to say, well, what model is going to work best for the particular features that are available to me in my problem space? And we've seen in Nerd tree-based models perform pretty well. We're using a lot of boosted trees because we end up with a lot of categorical and continuous features. There's a question that popped up in Q&A about, what if there are other rulings from lower courts that are mentioned in this document? How would that influence disambiguation? And yeah, the question, it ultimately comes back to that likelihood of those things appearing together. And so again, in the Wikimedia example, when we're using Wikipedia articles, we know in those Wikipedia articles, well, which things tend to be talked about together. And so again, if we have a ruling from a lower court, let's say mentioned in this same news article, well, if it's if it's the appeals court in Kenya, that again will help our decision making. Now, Nerd might get a little bit more confused if there's another paragraph in this document that says, there's actually a similar case to what happened in the US and in this year, in this ruling, in this court. So we do sort of have to weight these different things and look at those similarities across all the entities in the article.
Dominic, there are very good questions from Stephen about other ways to get there. For example, geolocation, the URL, maybe some of the metadata that's already there. Do you really need to go through all of the steps? Sometimes there are other components. How do you deal with that?
Yeah, absolutely. So if we know something like, hey, who's publishing this article? You know, is this a newspaper in Kenya? Well, that's probably a really helpful feature. So again, yeah, we have access to this other metadata in the article that could become part of our feature set. So that's kind of again, the beauty of this modular system is depending on what type of inputs you have, I can just go back to my feature generation step and add in those additional features. Now, if you come to me and you say, hey, I'm using these news articles, but actually don't have the sources on them, or I don't have those geotags associated with them, that's okay. We can swap those features out for something else or not use them. And so again, we can certainly use that metadata, and that is something that Nerd relies on pretty heavily when it's available. When that metadata is less available is when we have to rely on some of these additional features. And yeah, there's a question about using one-hot encoding for our categorical variables. Yeah, we're using light GBM frequently, and so it's often smart enough to handle things without us having to one-hot encode. And we also have a lot of categories or a lot of features that have many, many categories, and so choose not to one-hot encode those. But there are quite a few binary features that Nerd uses as well. So we've stepped through how we can mix and match these pieces together. And again, we started with the cartoon, we've got a little bit more detailed of a sketch, but I want to talk about how we actually do this in real code. And so at the end of the day, we take each nerd step and we define it using a JSON configuration. And so we have this base transformer, a mention extraction transformer that does that first step of nerd. And we configure it with a set of parameters. So in this case, we're just saying, hey, use this NER model from Spacey. We want to normalize the mentions that Spacey picks up. And we want to filter them down to organizations, people, and products. Those are the things we care about in this particular nerd pipeline. Below that, you see co-referencing, where we're configuring that with just a simple text overlap co-referencer. And how do I ultimately choose my representative of that cluster, what I'm ultimately going to disambiguate? In that case, I just take the longest text span. On the right side, I'm configuring my match predictor. So the last step of nerd when I'm making that disambiguation prediction. And so I'm passing it the model, where it is in S3 for nerd to go out and grab, and the features that I'm going to use. So I can tweak each of these transformers just by modifying my JSON config. And I can stitch together all of these configurations to make my list of transformers, all 5 steps, and then tweak that big config to give me different flavors of nerd without requiring any code changes. And so I can uniquely define my pipeline that I'm going to use for a particular problem based on this JSON configuration. And so this has proved really, really helpful for us. We actually started off doing this quite differently, where we were defining these objects for each nerd pipeline. And each nerd pipeline was a big object that took these 5 sub-objects. And we ended up just having this big repository with a ton of objects floating around. And as our number of nerd use cases grew, we really kind of outgrew this system. We needed something that was a little bit more flexible, that again took advantage of the modular way that we've built this. So again, by being able to just tweak a JSON config, I can give you a totally different version of nerd that maybe solves a different problem. Maybe the blue one up top is medical nerd, and then financial nerd, and then at the bottom we have Wikipedia kind of general purpose nerd. We can mix and match these components and just change our configuration to give us a new solution to a different domain.
And there was a question about long form versus short form and whether you can use a short form in a universe where you don't have a lot of entities. Have you thought about that, or how did you resolve for that?
Yeah, so we tend to use nerd in a longer form use case most of the time. So we don't really use nerd on things like tweets or other kind of super short content. Again, because we're tending to be pretty limited with the number of features we can pull from something like that. And we can't use those nice things like co-referencing or coherence when there's just very, very few entities mentioned in total. And so, again, we tend to lean more towards longer form content. But I would say longer form means like longer than a tweet, not so much like hundreds of pages.
What's the average processing time when you start thinking about it in terms of hundreds of pages?
Yeah, so I can kind of get into those stats a little bit towards the end, but
Okay.
yeah, Nerd runs, we usually can process documents within seconds, and the longest piece of the puzzle usually ends up being the first step, the entity recognition, because it's one of the most complex models that's in this pipeline. It's usually a large neural network model. And so that tends to be the slowest piece.
Thank you.
So I see some questions popping up. I'll address that in just a second, but I want to just wrap up talking about kind of the modularity and the mix and match nature of these nerd steps. So now that I've really talked up how easy it is to swap these things out and switch things around, is it actually possible to just say, cool, given two pipelines, let's swap the features, let's just totally mix and match like that? And the answer is, well, there still is some logic at play at which things are going to fit nicely together. If I swap my features around, but my model is expecting one set of features and now I'm giving it another, it's probably not going to work well. Some features, like we talked about earlier, are only going to work for specific data sources as well. And so we have to be a little bit thoughtful about which pieces we ultimately are going to put together at the end of the day. One of the nice things about this kind of JSON config way of defining a nerd pipeline is that it does make it really, really easy to test these different components as we mix and match them. So if I change how I'm doing, entity recognition at the beginning, let's say I swap in a model that has higher performance, I need to understand how that's going to affect everything downstream from it. And so with this nice configuration approach, I can do almost a hyperparameter grid search by comparing, okay, with this model and this co-referencer and this way of identifying candidates, what's my performance look like compared to slight tweaks on all of those. So that's my first takeaway that I have for you, is that by building Nerd in this very modular way, it's allowed us to adapt to different use cases, different problem spaces, without a ton of engineering overhead. We're able to take code that we've already written and reuse it, or take something that someone else has already written, let's say an open source model, and plug that into our pipeline. And so it's resulted in this system that is very highly adaptable to the nature of the problem that we face. Cool. So that's kind of the first piece I wanted to talk to you about, and we'll take a little pause for questions here. Let me read through some of these. So can Nerd identify co-reference for an outlier entity? For example, a speaker on an earnings call that implies a significant event maybe because of the rarity of their participation on previous calls. Inverse frequency would discount this entity person's value relative to the entity company. Yeah, so it certainly is, it is where Nerd gets into some of those edge cases where in historical documents, perhaps, these two things haven't appeared together. And so we have to look at things beyond just simple things like co-occurrence to solve this problem. And so we have measures of things like entity similarity that might be helpful here. So even if this particular speaker on this earnings call has never ever spoken up on this company's earnings call before, maybe we can link that person back to the type of industry that they're interested in or the company that they work for, and use that to get a notion of how likely they are to appear in this particular new earnings call that we're talking about. Let me know if you'd like me to follow up on that one. There's a question on what languages Nerd supports, and are we able to handle more languages with a single pipeline? So right now we've been doing Nerd purely in English language. And so that's kind of the domain that we have the skill set for. And it also is where there's a lot of those open source models and a lot of the kind of open source training data available. And so we're not right now using Nerd in other languages. But let's say you came, you said, hey, I have a really good NER model for Spanish, and here's my knowledge base already translated, all the entities translated into Spanish. That would be very easy to plug right into a Nerd configuration and then generate a new pipeline to handle Spanish language. And so right now, at least breaking it up that way, you would need kind of one pipeline per language.
Relatedly, there's a question in the chat. How do you decide when to retrain or to generate new models for they specify for the final pairwise scoring step, but in some respects it might apply elsewhere as well.
Yeah, absolutely. And so a lot of that retraining happens in kind of two cases. One is we're always working to grab the latest entity information for the knowledge base that we care about. So again, for Wikipedia, we are going out and grabbing every month. Wikipedia dumps out all of their entities, all of their articles. And so we do a ton of processing on that to convert it into a nice, clean entity knowledge base for Nerd. And so once we get that new knowledge base, we also have to retrain the associated models because feature values may have fluctuated. You know, maybe an article that has a ton of page views this month wasn't as popular this month, and then, you know, the month after that dropped even further. And so we refresh when we retrain when we update our knowledge base. So there's also a fair amount of ML ops at play here, where we're saying we need the tooling to actually go out, reach out and grab that new data and process it every month when it's released, or in some cases, every week when it's released, depending on the knowledge base we're using. The other time that we retrain is when we have new training data. And so there's a great team at Kensho that is actually creating new Nerd training data for us by hand. And it's a time-intensive process. But in cases where there isn't a lot of training data available, that's kind of our starting place. And so occasionally we'll have them review annotations that Nerd has already made and say, can you confirm this was, you know, yes, no, maybe here? And then given their feedback to the model, we can then pass that through and retrain again using their new annotations.
Do you have a preferred or an ideal number of documents to work with? There's a question in the, I'm skipping ahead to one of the questions from Tom Brown, because it seems to fit here nicely. You know, what size corpus, number of documents do you use? I mean, is there kind of a minimum? Is there an optimum number? And I'm guessing it comes up most frequently when you're doing retraining, but it could come up really when you're testing any kind of a new model.
Yeah, absolutely. So we're training Nerd on sub 100 documents usually. So it doesn't require a huge training corpus. Now,
Really?
within each of those documents, there are hundreds, sometimes thousands of individual Nerd annotations. And that actually ties in a little bit to what I want to talk about next, where we've worked to create some additional training data for Nerd. But we're using a very small number of these hand-labeled articles, or like I said, SEC filings, earnings call transcripts to train Nerd. And so that does lead to this kind of really constant hunger for new data sets. And I'll talk about next how we went about doing that.
You've officially blown my mind, under 100 documents. Wow.
So let's see, there's a question about transfer learning. And so absolutely transfer learning is something that we've used, especially for that first NER step. So I'm imagining a case or remembering a case where we took an existing general purpose NER model, a model that's pretty good at general named entity recognition. And we fine-tuned it for our particular domain that we were interested in this case, fine-tuning for the finance use case. And so we said, cool, you've been trained on a ton of general purpose documents. We're now going to train you on some earnings calls and some other financial texts to fine-tune on that domain that we really care about. There's a question about word embeddings. So we use word embeddings throughout the nerd pipeline. The first place that we use it is in the entity recognition step. And again, that depends on which model you're going to use, but a lot of these named entity recognition models are using some form of word embedding at the end of the day. And so I'll talk a little bit later about our Flare LSTM model. So Flare is a particular type of embedding. It's a character-based embedding. And we embed a little bit before and through the word, and a little bit after and through the word to get this kind of context-aware word embedding. And so we're using that at NER. We're also using embeddings at that NED step, at the disambiguation step, as a feature. And so something that we do, for example, is in the Wikipedia case, we embed the Wikipedia article for each of those articles in our knowledge base. Those are the entities we care about. And then we embed the incoming text, and we compare the embedding of the Wikipedia article to the embedding of the incoming text that we're disambiguating the entities in. And depending on how close those are, can give us a sense of the alignment of that particular candidate entity. There's a question on how do we evaluate this model on unseen data, which is ultimately the big question at the end of the day. And so certainly we're doing this in the classic way of having a holdout set that the model's never seen. And so whenever we're training a new model, we can run through that holdout set and gauge performance. But there's also this sort of human in the loop approach where we have this team that is looking at nerd annotations and giving us kind of a less quantitative, more qualitative feel as to, okay, is this behaving as we expect it to behave? And so there's both the quantitative and qualitative aspect. And we actually have a little, I guess you'd call it an integration test, maybe a regression test, that's part of a nerd deploy where we build the pipeline, we run that on the holdout set, and we compare that to previous runs on the holdout set and make sure that you're not deploying a pipeline that performs lower on the holdout set than previous runs. So that certainly is an important piece. How do you choose a model for a given step? And how do you handle the different parameter sets of the models in the JSONs? Yeah, so I talked about this a little bit where we really can treat that JSON configuration as a model itself that we can optimize those hyperparameters. So I can see, all right, if I change this one little dial here for entity recognition, let's say I no longer want to detect people with my model. If I turn that off, I can see how that affects performance of everything downstream. And so we have done some kind of these grid search optimization tasks to make sure we find the best combination of NER settings with co-reference settings with candidate identification settings. Let's see, do we use only neural nets for NER or some old-fashioned models like POS tags? So we're mostly using neural networks for NER models. You could, again, in theory, swap in any NER model that interested you. You could even do something very similar, like just do a control F NER model that says, find anything that matches a name or an alias in my knowledge base and consider that as a potential mention. So there's a lot of different ways you can approach this, but we tend to use a more complex neural network there. question about takeaway 2, we're getting to that. So maybe I should go on and we can get to some of these questions towards the end, because I want to wrap the content by 3 o'clock here. So
the good news is you clearly are sparking a lot of conversation. I do wish we were in person, but please continue. This is fabulous.
Yeah, it would be a lot more fun if we were all at a brewery right now, but
yeah,
we will make do. All right, so again, here's our nerd cartoon, and the two big models that are present here are recognition and disambiguation. So I'll give you the spoiler ahead of time that we were able to really improve these models' performance using data that we found totally out in the wild. And so we have these human annotators creating really high quality data sets for us at Kensho, but that's a very slow and arduous process. And there are a few kind of standard research data sets for this problem, and those are high quality, but they're also quite small and don't apply to every particular domain you might be interested in. So where did we go to find this data out in the wild, some good quality NER and NED data? Well, we turned to the Wikimedia Foundation. We're already using Wikimedia in Nerd, so let's see if we can convert things from Wikimedia, which is kind of the parent organization that includes Wikipedia, into some great nerd training data. So I've got here an article on the recent Hungatonga volcano eruption here. This was I don't know if you'll have read about this. Here's the satellite view, but this is a massive eruption that just happened and has affected many people. And here we have the Wikipedia article on this current event. And so I chose it not just because it's recent, but also because this article is very rich in entities. There's a lot of, especially places here, there's organizations. If we could convert this article into something that looked like this, a nicely labeled nerd document with all those entities highlighted and linked back to a database of our choosing, well, we'd be in business. That would be excellent. So we worked to create this process of going from Wikipedia article to nerd training data point. So you may, if you're squinting a little bit, see that there are already quite a few entities highlighted for us in this article. They're highlighted by the fact that they're hyperlinked. So Wikipedia has already done some of this work for us. Wherever we see a hyperlink, we can say, well, there's a good chance that's a named entity. And of course, that hyperlink links back to a Wikipedia page. And so we know exactly which entity this hyperlink is referring to. So that's our first pretty easy step, is grab all the hyperlinks in this article. But as you can see, not all hyperlinks may refer to things that we're interested in. So there are hyperlinks for things like eruption and tsunamis. Those aren't named entities. We have some things that could be considered named entities, but maybe we aren't interested in things like events. Maybe we're interested in places and organizations. And so only a subset of these entities are going to actually matter to us at the end of the day, and we want to be able to filter them down. To do this, we have to go and look at our Wikipedia article again. This is from the Wikipedia page for NASA. And we can see these nice properties that are associated with NASA in Wikipedia. This is the same little snapshot view you would get when you Google NASA. Google's just kind of stealing these properties from the Wikipedia page here. But these properties are actually a great example of the bridge between two Wikimedia projects. There's Wikipedia, the most common, the encyclopedia, and Wikidata, which is the catalog of all known entities that have been selected by editors in the Wikimedia Foundation and volunteers. There's actually way more entities in Wikidata than there are in Wikipedia, because in Wikidata, you just really need the entity name. You don't need a well-written article associated with it. And so we like to think about Wikimedia data like this. And if you've followed this meetup for a while, you may have seen us present on Wikidata and Wikipedia and use this graph. to show there's these three layers of a Wikipedia article. You have the text itself, the hyperlinks that we've been talking about, and then each of those hyperlinks refer back to an entity in Wikidata, this catalog of entities. We could consider Wikidata just to be a really great, really extensive knowledge base. And these entities are related by properties. So entities you see have this Q code, this QID as their identifier. Properties have a PID as their identifier. And they're related in this very rich knowledge graph. So we can see Grace Hopper is an instance of human. So that tells us what type of entity that she is. We can see all of these relationships across the entities mentioned in this article. And so the plan is to use this knowledge graph to translate these hyperlinks into their entity types so we can filter down to just the entities that we care about for our nerd problem. So let's do this for NASA, for example. In NASA, we go to its Wikidata page and we say, well, what type of thing is NASA? And it says NASA is an instance of space agency. Now, maybe that's helpful if you know you really care about space agencies for your particular nerd problem. We don't have anything quite that specific that we're using nerd on. So let's zoom out a little bit. Let's see what space agency is connected to on Wikipedia. Here, if we follow that knowledge graph, we can see that space agency is a type of government agency. Okay, that's nice. Government agency, going further down the rabbit hole, is a type of company. Okay, we're getting more general here. And then company is a subclass of organization. And so we've used the Wikidata knowledge graph to figure out what type of thing that hyperlink to NASA actually refers to. We now know that it refers back to an organization rather than a person or a place or maybe just an unnamed entity, a lowercase entity like eruption or tsunami. So it allows us to filter down the entities that we care about to just the types that really matter to us in the problem that we're solving. Now, some entities are a little bit trickier because Wikipedia, Wikidata, they're edited mostly by volunteers. And so if we look at something like Twitter, we see Twitter is an instance of, it's a service, it's an app, but there's nowhere in its instance of kind of graph, its chain of instance of statements that tells us that Twitter is also a company, it's an organization as well as a platform. And so we have to look at these other properties of each entity as well. We can't just rely on instance of, because those properties may not be complete, again, because this is constantly being edited and improved by other humans. But we can look at these other properties to get a more holistic view as to the type of thing that Twitter is. And well, things like revenue or employees are dead giveaways that we're dealing with an organization here rather than a person or a place or just an entity that isn't a named entity at all. And so by figuring out the types of things that we're hyperlinking to, we can actually filter down to just those that we want to include in our nerd training data set. So that's step 2, determine which links we actually want to keep around. Step 3 requires a little bit more careful reading here to notice that not all of our named entities are hyperlinked. So here we're actually missing quite a few. And it's not due to incompleteness on the case of Wikipedia. It's actually just the case that they only hyperlink the first thing, which makes sense. The purpose of the hyperlink is, well, if you don't know what this is, you can click out to its source article. But there's no need to do that every time the entity shows up. And so we notice that we're missing a few entities in our training data set here. So the next step that we have to do is perform some annotation propagation. We say, all right, I know Fiji is an entity in this article. Let's look at Fiji's name and any aliases present and propagate to mentions of that name and alias later in the document. So now we've got much better coverage of the entities that were present, even the ones that weren't hyperlinked. So we grab the hyperlinks, we filter them down to just the things we care about, we propagate, And then the last thing is we apply our identifier. We actually have to link this back to the knowledge base that we care about. Now, if your knowledge base is Wikipedia, well, you're in luck. Your job is already done because these are already linked back to Wikipedia pages. If you're not using Wikipedia, you can also use the identifiers that are present again in Wikidata. And so Wikidata can help you link back the things that you found in this Wikipedia article to other databases that may be of interest to you. And so that's the final step in converting this into a nerd training data article. So by following this process, we can do this at great scale, right? We can run this on every Wikipedia article, and we can even be picky because there's so many of them and still result in a really, really big training data set. And so maybe we say, well, I only want the articles that are about these particular topics. Or maybe, if things aren't ever hyperlinked in the Wikipedia article, well, then this process doesn't really have a chance of picking it up. So maybe I filter down to just the ones that I think have a more complete entity coverage. And so we can narrow down these articles that we've now tagged in this really automated fashion and use those to train an NER and an NED model. As a little aside, if you're interested in learning more about this Wikimedia dataset, we have open sourced it on Kaggle, and I'll link to that at the end of this talk. So that's the second takeaway is, well, how do we actually train these models? We're using human annotations, certainly, but we're also using these automatically generated annotations that we're getting from Wikimedia. And so I want to actually show you some of the visualization of how this has actually helped. Here's our one of our NER models, and I'm showing you the baseline in red, and then the addition of that Wikimedia data set in green. And for even a little bit more of a zoom in here, this is using those Flare word embeddings that I talked about earlier. It's passing those embeddings to an LSTM model. And this is using our custom data, and it's using Onto notes, which is a very common NER data set in the research community. We've done kind of all the standard optimizations and little tricks for training a big neural network and improving performance. But at the end of the day, what really made the difference was adding more data to the problem. And so it was a great help that through this process, we could generate that data without a ton of human annotator hours.
So can you, that is a very subtle point. Earlier in the conversation, you talked about training your models on a corpus of like 100 documents. And now you're talking about the value and importance of a larger data set for other training. Do you want to maybe unpack a little the nuance there? Because it's important.
Yeah, absolutely. And so I think it comes down to at the end of the day, only hundreds of these really high quality human labeled data points. And so we could either invest the time in having human annotators create a very small number of additional documents to train on, or we can create what I wouldn't call a gold data set, maybe a silver quality data set in this automated fashion. And so for a large capacity model, like a big neural network model that we're using for NER, we really see the improvements when we add in this kind of silver data set. And it's similar to how we can see better neural network performance by doing things like pseudo labeling and self-training, where we're adding in data to train our model that we know isn't perfect, but it's of pretty good quality and allows our model to sample more of the space at large. And
Can you provide a sense of scale though? Proportionately, how much larger is the open source data set relative to kind of the human curated data set?
Yeah, and so we actually, because we had the option of such a big open source data set through Wikimedia, we had to find the right ratio of how much of this kind of open source Wikimedia data to add
Yeah, it's tricky,
to
I know.
how much of this, really high quality hand labeled data that we added. And so we found actually at these higher ratios, if you were including, 10x Wikimedia data compared to your, really high quality gold data that, also was really channeled to your particular domain, we didn't see as much of a performance improvement. And where we actually found the best ratio to be was closer to 1-to-1. And so we're not 10xing the amount of data our model is seeing, we're closer to doubling it. And so again, it's double your data is pretty great. And to be able to do that.
Well, Dominic, that's a topic for another entire session. I could ask a million questions about that, and I don't think I'm alone.
Absolutely, absolutely.
But I don't keep going.
Sounds good.
Sorry to.
So the last thing I want to talk about, this is really a bonus takeaway, is that we also tried to include transformer models in this NER horse race that we're doing here. And of course, transformers are the hotness in NLP these days. They are, putting up state-of-the-art numbers in just about every natural language problem that you can think about today. And so we were very surprised to see that a transformer-based architecture didn't outperform this older LSTM-based approach. And so this isn't a straw man graph that I'm showing you here. This is actually many, many iterations of a transformer model, many, many different experiments in the order of hundreds to try to get our transformer to match this older technique of the LSTM. And so I won't go too deep on this point, but I think it's a little side takeaway perhaps, that just because an architecture is putting up really good numbers on your standard research data set doesn't mean that it's going to be the right fit for your particular problem. And we found that in training these NER models by comparing RNN-based architectures to transformer-based architectures. So that is what I have for you all today. To recap, by building NERD in this modular way, we've been able to adapt our models, write less code, do less work to reach many, many different problem spaces and customer use cases. And two, we did see that adding data to these models, in particular data that we generated from open source data sets, was able to really give us a boost in performance. And then this bonus takeaway here, again, that it's not always the right solution to just plug in the latest and greatest model. It takes a lot of work to tune that and to get that to fit your particular problem. And you're certainly not guaranteed that that's going to be the best performer. So that's what I have for you all today. I am excited to dive into some questions here. If you need to drop, I know we're already over the 3 o'clock hour. Here's my email if you'd like to reach out. We talked about the volcano. If you're interested in learning more about that, maybe donating to help, there's a link there. If you want a free trial of NERD and you want to start throwing some documents at it, seeing if performance measures up to the hype that I've been giving you here, you can try that link. If you're interested in that Wikimedia data set, there's a link for you. And then Kensho is hiring. So if you are a data scientist and this kind of problem interests you, if you are a data engineer or a front-end engineer, and this kind of thing sounds cool, we'd love to talk to you more. So there's one last link for you. And with that, I'm going to head over to the Q&A and answer some questions.
And while Dominic is reading the questions, we know not everybody can stay. This was recorded. It will be posted on the meetup if you need to drop, so you won't miss part of the discussion. And we thank everyone. We had a great audience, and we thank you all for joining. But Dominic, if you've got time to answer a few more questions, go for it.
Absolutely. Yeah, I will stick around. So happy to keep the discussion going, but yeah, no pressure if you need to drop. Let's see. So question on how would NERD fare against a literary text in which the extra textual references would be limited and defining entities and domains would be arduous, such as Lord of the Rings. I'm a huge Lord of the Rings fan, so this is a great question. It's funny, our test set when I want to just explore using a subset of Wikipedia is I often take the subset of Lord of the Rings characters and related articles. But yeah, that would be a challenging domain, I think, again, because you're limiting some of the context and features that might be available in something that's referring to maybe a real world situation. But again, if you were willing to define that knowledge base, I think Nerd would be successful at the end of the day. If you had those features about those entities, and Wikidata actually has a pretty rich knowledge graph, even for Lord of the Rings entities. So you can understand how these different characters relate to each other and how likely these characters are to show up together, Oh yeah, Aragorn, he's a third age, fourth age kind of guy, but oh, this character actually belongs back in the first age. This is someone from the Silmarillion. That data is actually in Wikidata, which is pretty cool. And so it really would depend on the strength of your knowledge base and your willingness to kind of define those features. But certainly you would miss out on some other features like we have for companies. Let's see, how do you choose a model for a given step? And how do you handle the different parameters of the models in the JSONs? Yeah, I think this comes back to, again, treating that JSON configuration as itself kind of one model that we can hyperparameter tune, and we can try out different combinations of these models and of these model setups. And so we can say, all right, I'm going to use this NER model, and I'm only interested in these entity types. But I can now swap in, okay, Spacey just released a new model. I'm going to try that one and see how that affects my pipeline downstream. And so at the end of the day, these are empirical questions, and Nerd makes it really, really easy to answer those empirical questions. There's a question if NLP ever does a continuous retrain rather than a periodic update. I think this is pretty hard to implement to, essentially have my model being trained or, learning on a new instance every time that new instance is labeled. It's much, much easier from sort of a ML ops perspective to do these periodic updates rather than to try to learn on every single instance that gets labeled and comes back to us. And so, yeah, I think we really prefer those periodic updates.
Just a detailed question for you on that. Human language evolves, and but it evolves slowly. In certain domains, it evolves quickly. Have you done any research on the rate of change of language and reference rates?
Yeah, we don't have a huge amount of monitoring there. Kind of to counterbalance that is what I talked about earlier with doing the refresh of our data. So we're not just kind of growing our data, but we're actually going back and refreshing it with the latest, let's say, Wikipedia dumps, or in our company knowledge base that's constantly being refined, and new companies are being founded every day and being added to this database. We need to make sure we're pulling that and refreshing our data accordingly. And so that's kind of how we try to keep ahead of those changes in language.
Thank you.
Yeah, you're welcome. Is Nerd Python based? The answer to that is yes. Asking about system resources. So yeah, there are two big concerns here. One is running a larger NER model, if that's something that you're doing. Now, some kind of solid NER performers can be run on CPU or can just be run really, really fast on a not high quality GPU. So I'm thinking of some of the Spacey models are convolutional neural nets. They're CNN models that run really, really quickly. If you're going to use that versus a transformer, you're going to need a lot more kind of GPU firepower for the transformer. And so that's another trade-off that we consider when kind of assembling these nerd pipelines is, well, what does this customer really care about? If they care about speed, let's use our simplest model that gives still solid performance. If they really, really need high performance, but they can get this document a couple seconds later, then let's use maybe that transformer architecture or our heavy duty Flare architecture that's going to run slower. It may cost more to run, but is going to give higher performance. So that's kind of one constraint is the compute. There's also the memory constraint of how we actually hold all of those entities. And so there are two approaches to do this. Again, it's a performance trade-off here and also kind of cost trade-off of, do you want to hold that whole set of entities in memory, or do you want that to sit in a Postgres database that then Nerd is going to query when it says, all right, I need candidates for this text span, Kensho Technologies, that's going to send a query off to the database and get results. It's going to be a little bit slower, but it's also going to require less memory at the end of the day. And so again, it's a configuration based on the need of a particular customer there. Let's see. All right, so financial and medical data was talked about and can contain sensitive information. When you extract entities and can't be 100% sure of the entity type, so let's say the model predicts an entity to be an organization, but it turned out to be a person, is there a good chance you might be sending sensitive data while getting candidates through Wikimedia, or do you have a way to work around this? Yeah, it's a good question. We haven't used Nerd in a ton of situations where there is that kind of personally identifiable information. And so we haven't done a whole lot of thinking around that. But you're right that certainly in the financial, medical, legal cases, there can be that. And so I think it's something that we'd have to think about if we were approached to solve that particular problem, but it's not something that we've worked on at this time. Let's see, someone wants to create a network of composers based on Wikipedia data. I don't know of a similar project, but I would I'd look at Wikidata first and see what's in there, because I think Wikipedia is the go-to, but people often forget about that sister project, Wikidata. And there's often a wealth of information in there that is present because it's a lot easier to write something as a property, saying, Beethoven's father was so-and-so, as opposed to writing a long form article. And so Wikidata often has more than Wikipedia has. Can you show a couple of interesting error cases? What if the knowledge base is ephemeral or unreliable? Yeah, this is a great question because, in fact, all knowledge bases are going to be unreliable in some sense. They're all being curated by humans at the end of the day. And so we've had cases where Nerd has made really strange decisions, and we've had to kind of do this forensic analysis of, well, how on earth did they get to that conclusion? So for Wikidata, we're working off of these dumps that Wikidata says, I'm saving all of Wikidata on March 1st, 2022. That's when we're going to do our next poll. Well, at one point, someone changed the title of the Wikipedia article for Twitter to Twitter's name in Korean, which shouldn't be the case in English Wikipedia, which is what we're pulling. But it just so happened that in the brief 1 hour window before someone at Wikipedia noticed that and fixed it, that was when they did the snapshot. And so we had that company mislabeled in our knowledge base because, well, we're working with Wikipedia, and Wikipedia is run by humans. The same is true of our company knowledge base that, I mentioned the aliases were sparse. Sometimes Nerd has been unable to get something that we would think, wow, this seems pretty easy, the Fed. Well, we all know the Fed refers to the Federal Reserve, but in our knowledge base, there's no alias for the Fed. It's only called the Federal Reserve or the Board of Governors of the Federal Reserve, which makes it a lot harder for Nerd. And so again, this problem is solved by making sure that we're constantly updating, constantly pulling in the latest data. And a lot of work is required in doing that. It takes a lot of compute to process all of those Wikipedia articles, but it's important to us because there are often gaps just because of the human generated nature of them. There's a question on combining, I talked about kind of gold versus silver data. And Barbara, you asked about this a little bit as well, kind of the ratio at which we compare them or combine them, I should say. So this is also a kind of a hyperparameter that we thought about when training this model is, yeah, I was excited because we now have this massive quantity of silver data. Let's throw that all at the model and see how it does. And it turns out that's not as good as showing it that 1-to-1 ratio of gold to silver, or saying, I'm going to give you a higher amount of silver data, but I'm going to, in my loss function, weight a mistake on the gold set higher than a mistake on the silver set. And so we've tried that as well. So those are two approaches to combining those two different types of data sets.
It's intuitively attractive.
Let's see, do you have any external data, generated data sources you use for training the NED model? That must have been asked just before we got into that second section. So yes, we're leveraging a lot of great stuff from Wikimedia there. And then do I have a hypothesis on why the LSTM performs better than the transformers for my particular application? I really don't have a great intuition for this. I think, again, this was kind of a surprise, and we worked pretty hard to try to get that transformer to match the LSTM's performance. I think that at the end of the day, for the particular domain that we were in for this NER model, that this character-based embedding was stronger than the embedding that the transformer gave us. And while this transformer gives us access to, these things all throughout the sequence of words, of word chunks, it seems like we maybe needed just a shorter amount of context, and that's more what the LSTM provided to be able to make a good prediction. And so those are kind of our two thoughts on that at this moment. But again, it was really a surprising result. Do I see issues with NERD connected to discussion around ethical AI and unconscious bias in data sets? Yeah, I think, again, we're training NERD on these human-generated data sets. And so there is going to be bias in those data sets. So for example, in Wikipedia, there are fewer women with Wikipedia articles than men. And it's working now, and we've actually done some work with them to help write some articles to balance, for example, women in STEM, and add some female scientists and engineers to Wikipedia. But at the end of the day, we are limited. We're using this human data. And so where bias exists there, that may translate to bias down the road in our NERD model, or that feature like page views being a feature for Wikipedia articles. If a page isn't viewed as frequently as another page due to perhaps some kind of bias or discrimination, that is also going to persist through into our NERD data set. And so we have to be really aware of these things and consider that when we're building these data sets. And again, part of the work that we're doing to address that is to do something like, they call them edit-a-thons for Wikipedia, where we've gone and actually, folks at Kensho have written Wikipedia articles to help balance out some of this bias. Question about adapting NERD to work on dialogue or chat data. So NERD works really, really well on dialogue already. One of the main contexts I'm talking about here is earnings calls, where there's a huge Q&A section at the end that's being transcribed. And we have these dialogues where it's just quote, responding to quote, responding to quote. And so NERD performs very well, and it's an area where we've particularly sought out some training data there. In terms of chat data, again, I think it comes down to what you're passing to NERD. If you're passing to NERD each individual snippet of the chat, it might have a more difficult time than if you provided that whole transcript where it could find entity, relationships and look at the full context of the conversation. But it is already proven out on dialogue through things like earnings calls and investor presentations, things like that. Can NERD integrate proprietary knowledge metadata in addition to its wiki knowledge graph? Yes, absolutely. So we are using some proprietary data sets where someone says, hey, I don't want to open source this, but I'm interested in NERD picking out these entities. Then certainly if you provide that knowledge base, we can use it. Or if you have even additional data on a knowledge base we already have, we can plug that in as features. And again, that's the beauty of that modular system, that we can mix and match, and we can say, oh, well, company X is giving us their really high quality database on lawyers and judges, let's say. We can use that for only their NERD pipeline and no one else's. So yes, we have integrated proprietary knowledge bases. Question about the architecture overall. And so we do deploy the entire NERD pipeline usually on one machine, but we've also tried approaches where we split up the NER step from the other 4 steps. And so that's because the NER is typically being run on a GPU machine, and the rest of NERD doesn't require that GPU resource. This requires a little bit more overhead in the architecture, but it saves us a little bit of compute resource. And so that's something that we've done in the past. Are Kensho employees working from home nowadays? Yes, this is my, you can see by my background, I'm not in the office, I'm at home. And yeah, Kensho's been very thoughtful about just making sure people are comfortable with return to office. And so offices are open if people want to go work in them, but they're not requiring anything. So yeah, I've been very grateful for Kensho's COVID response. How do you handle compatibility between transient features, between training data and input data? For example, you update your Wikidata knowledge base in 2022, but a customer feeds in an article from 2021. So we kind of have this backwards data drift. It's a great question. So there's a kind of follow-on question to that, asking if Wikimedia is versioned. And so yes, Wikimedia does come with a version. It comes with kind of the date stamp, the time stamp that dump was taken, so that we kind of froze the Wikipedia data and we exported it as one big SQL dump or one big CSV. So if we know that our Wikipedia database comes from a particular time, we can certainly change that database to suit the inputs. The other thing that we're doing is we're trying not to throw away data from, let's say, an old knowledge base, but let's say a company changes its name, like Facebook is now Meta. Instead of just saying, cool, forget Facebook ever existed, we actually would just change Facebook into another alias for Meta. And so we're trying to not throw things away unless that data was actually incorrect. And so part of that is really helpful. Wikimedia does that. The company knowledge base, we're using our parent company S&P's knowledge base of companies. They're doing some of that work to say, this name changed, this old name is a historical name, versus, oh, actually this name changed, this old name is just an error, someone had a typo there. So yeah, we're trying as much as possible to not ever be throwing away past information. But in the case that you're like, hey, I'm running a bunch of really old reports from let's say from the 1990s, I guess there wouldn't be Wikidata dumps from then, but let's say I'm running reports from 5 years ago, maybe you would you could even select to, again, just swap out your knowledge base for a knowledge base that better suited your input documents. A question about getting access to Nerd via Okta. I think you'll have to click on support there on that page. Unfortunately, I'm more focused on the ML and less on the auth side of things. So hopefully there's a link there, but you can always shoot me an email and I can forward you on to the correct person there. So yes, Nerd is Python based, but it is proprietary to Kensho. And so there aren't pieces of Nerd that are open sourced. However, there are pieces of our Wikimedia processing code that are open sourced. So if you look up Kensho on just regular public GitHub, you'll see that we have some repositories, and anything that begins with KW, Kensho Wikimedia, refers to those code bases for processing the Wikimedia data. And so, yeah, we want to encourage other people to use these data sources, and that's one way that we do it. Sounds like this knowledge base has a US-centric bias, but in some contexts, the salient point about NASA is that it's a US space agency, or that NASA is public sector versus SpaceX being private. Yeah, absolutely. So we actually do capture some of those features as well. And again, it comes down to the richness of Wikidata. It comes down to the quality of our kind of proprietary company's data set. But in Wikipedia, you can see features for public sector versus private sector. When was it founded? Where was it founded? Is it a US space agency or is it a Russian space agency? It's very easy to find that on Wikidata. Now, again, you're limited by what exists in Wikidata. If no one has filled out that property, then we don't know, that's just a null field in the database. But it tends to, for the more common entities, those tend to have the most context and the most properties filled out on Wikidata. Can I quantify the full training cycle at a high level? So time, cost, server resources. Yeah, so the training of the NER model, again, we're training different NER models for different use cases, but those can definitely span hours on a GPU machine. And so I think at the longest, we're talking orders of less than 20 hours, certainly at the very, very longest, but we're not doing a ton of like these very, very large, complex, like let's train this for 3 days kind of model. Usually our NER models are training over a span of less than 5 hours. And then training the NED model, it's actually doing the disambiguation, trains really in minutes on a CPU machine. It's because we're not doing anything super crazy there, the work is really in generating those features. We're then just passing that to a tree-based model at the end of the day. And so that trains on CPU within minutes. So it's not a huge amount of lift to do the new training. I think where the bigger lift comes in is in processing that Wikipedia data and processing our new proprietary knowledge bases that are coming in. Those are, Wikidata itself is in the order of tens of gigabytes. Just to download that from the Wikimedia mirror takes a long time. And so I think we do some of that more upstream processing kind of, that's not being manually kicked off by someone every single day or every single month. That's just being run in the background. And then we know we have new Wikimedia data that we can use later on. But ultimately training our models is it's also part of that kind of automated pipeline. So the idea is when new data comes in every month, that's going to kick off a chain of events that's going to retrain everything.
And Dominic, you're using basically supervised machine learning so you can understand the outputs. Am I right? Or are you also using full AI?
Yeah, we are doing supervised learning here.
Yeah, that's what I thought.
So, yeah, everything has a label, and that's how we're evaluating against the holdout set at the end of the day.
Excellent. Well, as much as I know I would personally love to continue the conversation, I'm very aware that we're 30 minutes past our close time, and we've had a lot of people stay on, which is great. But I want to be respectful, and it's now going to be a long recording. And so I know that Kencho is quite the valuable contributor to this meetup. So I'm hoping that some of the ideas and questions that we didn't get to discuss, or at least not in great detail, we can come back to at another point in time. But I think we probably should wrap up.
That sounds good. Yeah, thank you all for attending. Thank you for the great questions and discussion. It's been really fun to share some of this work with you all. And like I said, I'm available offline if you'd like to chat further. My email address was up there for a little while, but you can always grab it off the recording, or you can just find me on Meetup as well.
Thank you for the really the thought-provoking conversation and presentation, and thank you to everyone who participated. Those were great questions, great engagement, and we will see you at the next one.
Sounds great.
Thanks so much.
Everybody.
Take care. Bye-bye.